Classification of parsers. So parsers are mainly divided into two types, top-down parser and bottom-up parser. And top-down parser is again subclassified by using backtracking and predictive parser. Bottom-up parser is classified by using operator precedence parser and LR parsers. And LR parsers are again subdivided in the form of SLR, CALR, LR and LALR. So let's start discussing top-down parser. The process of construction of a parse tree starting from root and proceed to children is called top-down parser. That is, starting from start symbol of the grammar and reaching the input string, it is called as top-down parser. So if we are constructing a parse tree starting from the root and proceeding towards its children, then it is called as a top-down parser. So in top-down parser, we have this following process, that is the recursive descent parser and backtracking and non-backtracking. In non-backtracking, we have again predictive parser and LL parser. So we'll discuss what is the meaning of backtracking and non-backtracking. For example, consider an example for top-down parser, that is S tends to AABE, A tends to BC, B tends to D, and the input string is, that is the string we need to derive is A, B, C, D, E. So let's construct the parse tree now. So as we said, if we are going to construct the tree starting from the root and proceed to its children, it is called as a top-down parser. So here the root node we are considering as S, and S tends to AABE. So S tends to AABE. So again here A tends to BC, A tends to BC, and B tends to D. So the input string we need to derive is A, B, C, D, E. A, B, C, D and E. So we have derived the input string from the given grammar by using top-down parser. So top-down parser is also known as a recursive parser or predictive parser. Top-down parser internally uses leftmost derivation. It is constructed for the grammar if it is free from ambiguity and left recursion. So in top-down parser, the grammar should be free from ambiguity and there should be no left recursion. The following are the problems associated with top-down parsing. Those are left recursion, left factoring, backtracking and ambiguity. So in order to use the top-down parsing, these all should be eliminated. So first one is left recursion. What is the meaning of left recursion? A production of grammar is said to have left recursion if the leftmost variable of its RHS is same as the variable of LHS. So when we call a given grammar is having left recursion, if in a grammar, if the leftmost variable, that is towards the starting symbol in the left hand side and in the right hand side production, if both are same, then that is called, that grammar is said to have the left recursion. So we need to eliminate such type of left recursion. A grammar containing a production having left recursion is called as left recursive grammar. Left recursion is considered to be problematic situation for top-down parsers. Therefore, left recursion has to be eliminated from the grammar. And left recursion is eliminated by converting the grammar into right recursive grammar. So we can eliminate the left recursion grammar by converting it into right recursive grammar. So there are some steps to eliminate the left recursion. So how it is done, we'll see. So elimination of left recursion. So top-down parsing cannot handle left recursion. So for example, consider if it is in the form of, if the grammar is in the form of A tends to A alpha or beta, then here alpha and beta are strings. So we need to write all the symbols in the non-left recursive production. So here first check. So we have considered here a grammar like A tends to A alpha or beta. So how can we check whether that is left recursive or not? if the production in the right hand side and the production in the left hand side, if the starting symbols are same, then it is called as left recursion. So here the starting symbol is A and here also the starting symbol is A. That means this grammar is having the left recursion. We need to eliminate this left recursion. So in order that we are using the following steps. The first step is you need to write all the symbols in the non-left recursive production. So what it means? So consider here A tends to A alpha. It is the left recursive production because here this symbol and this symbol is the same. That means this is the left recursive production because it starts with the same symbol as A. Here this side also we have the A and here also we have the A. So A tends to A alpha is called as left recursive production. And so here what is the step we need to write? First step is we need to write all the symbols in the non-left recursive production. So what are the non-left recursive production? Beta is the non-left recursive production. So first what you need to write? A tends to beta. You need to write beta first, and after that what we need to write? Write non-recursive production beta. We have written the non-recursive production beta, and then introduce a non-terminal symbol which is related to this starting symbol. So as we are using the starting symbol A here, I am introducing a new symbol like A dash. If we are using the starting symbol as E, then you can introduce a new symbol as E dash. So in order to eliminate the left recursion, the first step is first we need to write all the symbols which are there in the non-left recursive production. So there should be the production should be non-left recursive. In that whatever the symbols are there, that we need to write first, and then immediately you need to introduce a new symbol which is related to the starting symbol. This is the first step. And the next step is we need to derive for A dash also you need to derive this. So A dash tends to, so how you need to write here? Write all the symbols except A from the left recursive production. So except this starting symbol, whatever the symbols are there, that we need to write from the left recursive production. So in the given grammar, except A, what are the symbols left over here? Alpha. So A dash tends to alpha, and then rewrite A dash. So we have introduced a new symbol now, so that we need to rewrite here and then write epsilon. Clear? So the first step in order to remove the left recursion is write all the symbols in the non-left recursive production and then introduce a new symbol related to the starting symbol. So this became as A tends to beta A dash. And then we need to write we need to derive this A dash also. So A dash tends to, so how we need to derive? We need to write all the symbols except the starting symbol in the left recursive production. So remaining symbols you need to write. So the remaining symbol here is only alpha. So alpha I have written, and then write the you need to we need to write A dash, that is the new symbol which we have written. We need to write the A dash and then epsilon. So these are the steps to eliminate the left recursion. Consider an example for to eliminate the left recursion. S tends to L and S tends to A, L tends to L comma S or S. So here first we need to check whether it is left recursive or not. So in the given grammar we have two strings, S tends to L or A. Here it is starting with S, the right hand side production starting with S, and the left hand side production is starting with L or A. So this is not a left recursive. Now check this second inputs grammar, that is L tends to L comma S or S. So here right hand side and the left hand side starting production we have the same symbols. That means it is left recursive. You need to remove this left recursion. So we need to remove the left recursion in this grammar. So first as it is you can write S tends to L A. And now L tends to, what is the step we have told? First write the symbols which are there in the non-left recursive production. So this is the left recursive production till here. L tends to L comma S is the left recursive production. L tends to S is the non-left recursive production. So the symbol which is there here is S. So L tends to S, and then introduce a new symbol related to the starting symbol. So the starting symbol I have taken as L. So I have introduced a new symbol as L dash. So now for L dash also you need to derive the grammar. So L dash tends to, what is the step I told? Write the remaining symbols except the starting symbol in the left recursive production. So the except the starting symbol L, the remaining symbols are comma S. So comma S, and then introduce the new symbol, the same symbol, that is L dash, and then epsilon. So this is the grammar after removing the left recursion. So consider another example. E tends to E plus T or T. T tends to T star F or F. F tends to ID. So in this we have the left recursion, that is here we have E, and left side and right side the starting production we have the same symbols, and in this grammar also we have left recursion T and T. Only in this string we don't have the left recursion. So in this both we need to eliminate the left recursion. So for that E tends to T E dash, and for this E dash also you need to remove. E dash tends to write all the remaining symbols except the starting symbol. So all the remaining symbols are plus T, and then write the newly introduced symbol E dash and then epsilon. And for this T tends to T star F or F. So T tends to write the non-recursive production, that is F, and then introduce a new symbol related to the starting symbol. So Ft tends to F T dash, and for this T dash also we need to derive. T dash tends to, so whatever the remaining symbols are there in the recursive production, that is star F, and then T dash or epsilon. So and F tends to ID. There is no left recursion in this. So this is how we eliminate the left recursion from the given grammar. And the next one is left factoring. Left factoring is a process by which the grammar with common prefixes is transformed to make it useful for top-down parsers. When two or more productions are starting with same set of symbols, then we will get confusion which of the productions are used to expand the non-terminal. So we need to do grammar transformation called left factoring to avoid the confusion. In left factoring, we make one production for each common prefixes. The common prefix may be a terminal or a non-terminal or a combination of both. Rest of the derivation is added by new productions. The grammar obtained after the process of left factoring is called as a left factored grammar. So, what is the meaning of left factoring? So, in the given grammar, if it consists of, if there are two productions, if we have more than one production, so we doesn't know when constructing the parse tree, we doesn't know which we need to consider, which symbol we need to consider. We will have a confusion which production we need to consider from this. So for example, consider here A tends to alpha beta 1 or alpha beta 2. So here we have two productions here, so we will have a confusion which to use. So then in this is called as a left factoring. So here you need to remove the left factoring. So in order to remove the left factoring, first what we need to do, we need to write all the common symbols from the production, and then you need to add a new symbol. So check here, what are the common symbols? A tends to alpha beta 1 and alpha beta 2. So in the given production, what are the common symbols? Alpha and alpha. This is the common symbol. So A tends to, the starting symbol you need to write same as it is. A tends to write the common symbols. So what is a common symbol? Alpha, and then introduce a new symbol related to the starting symbol, that is alpha A dash. Now we need to derive the grammar for this A dash. So how we need to derive A dash? In that you need to write the remaining symbols from the production. So from the given production, what are the remaining symbols are there, that we need to write in the A dash. So A dash tends to beta 1 and beta 2. So left factoring is nothing but in the given production, if we have same set of symbols, that is if for one production we are having same symbols, when constructing a parse tree we'll have a confusion like which one to use. Now here A tends to alpha beta 1 and alpha beta 2. So we will have a confusion like which one to consider first. So this is called as a left factoring. So whenever this type of problem occurs, you need to remove that left factoring. So that for that we follow two steps. That is nothing but in the first step we need to write all the common symbols from the production. Okay, write all the common symbols from the production and then introduce a new symbol related to the starting symbol. And the second step is write all the remaining symbols from the production. So now take another example. S tends to IETS or IETSES or A, and E tends to C. So check here whether it is left factoring or not. See here, S tends to IETS, IETS or A. So here the starting symbols are same. So we doesn't know which one to use first, either IETS or IETSES. So that's the reason this is called as a left factoring, and you need to eliminate the left factoring. So after eliminating the left factoring, this grammar becomes as S tends to. What we need to do first step is write all the common symbols. So what are the common symbols we have here? IETS. Here also we have IETS. So this is the common symbol. So write IETS and then introduce a new symbol related to the starting symbol. So here the starting symbol is S. So I have introduced a new symbol as S dash. Okay, and then we have here A, that A I have written here. So for S dash also you need to derive. So S dash tends to, how we need to write for S dash? You need to write the remaining symbols from the production. So in the production, what are the remaining symbols? Here we have IETS. No more symbol is there here. That means you need to consider epsilon here. Epsilon is nothing but, we doesn't have nothing. If there is nothing there, we consider it as epsilon. So here you need to write as epsilon, and here IETS, this we already used. What is the remaining here? ES or ES. So S dash tends to epsilon or ES. And the next production is E tends to C. So as it is, we need to write as there is no left factoring there. So this is how you remove the left factoring.